Okay. Welcome to the third week computer science class. And today we're going to focus on function two. Function two, we have discussed about the regular Python function last week, about the definition, the calls, and then the environmental diagram. Okay, so today we have to discuss further about Python, like some different functions other than regular functions, and then um, the C++ version of at DVC is covered in Computer Science 110 and 165. And the study goal is to talk about pure and non-pure function, and then what is a lambda function, and how's that look like in an environmental diagram. So I suggest you guys prepare your iPad or prepare a pen and a piece of paper so you can draw the environmental diagram with me so you can know how to keep track of the values. Before jumping into all these topics, we review environmental diagram first. Yeah. Um, Environment is actually a kind of range carrying values and functions in the coding file. So it's like you see, imagine the Earth, and you have many countries on it, like China, the US, Canada, and they have ranges, and they are carrying people, carrying houses, etc. So um, yeah, so it's like environment in Python, and at that uh, at this place is the variables and functions, they may have the same names, but they are having different values and different behaviors because they are in different environments. Okay, so it's very similar to the idea of scope. It's actually the same thing, but we call scope in C++ and we call frame in Python, and they are all discussed about environment. And then a function call opens a new frame. So we have function definition, function call. Function definition does not open a new frame. Function call opens a new frame. Okay, so this is an example of environmental diagram. So it's like um, when you have the code here, so it will evaluate from top to bottom, from here, from top, and then go further down. So it's like they know x is 1 and y is 2, z is 3, and reach that function 1 is a function object. Okay. So a function call creates a new frame, and um, the frame where the function is defined is called the parent frame. And then the name of the frame, we call that 1F1, F2, F3, etc. So to no, it's different from the global frame. So when the function is executing code, the function definition will be skipped. Like the function code, the codes, the program, they can only recognize function definition. Once they hit them, they are not going to be run. They will run when the function is called. Yeah, and a new frame will be created. So a function will be run in the frame it creates. Okay, and the function is running. Um, it will look up into the parents frame, parents frames, parents frames if the variable cannot be found in the frame, like the variable definition. So for example, we have x equals 1, and we have a function define, and then is x, um, you return, oh, sorry, suppose, so x is 1, and define function say y, and then return x, and we have solution equals to func 0. So we want to find when we run in this function call, we want to find where x is, but we can't find x in this frame, so we will look it up in the global frame. Yeah. So we see like x is 1, so we return 1. So Yeah. So if you cannot find the variable in global frame, eventually you return a name error because the program can't find the variable you're looking for. So it will return it will return an error. So this is name error. Mhm. So I've discussed about this environmental diagram for a little bit. Mm, yeah. Oh, I don't think I have used it. So for here, we we read the codes from the top to the bottom, and we'll hit the x equals to 1 line first. So we will see like we have x equals to 1. So the next step is y equals to 4 and z equals to 9. And we hit the function definition. So as I said, the function definition will be recognized, but will be skipped. It will not be run until it's called. So we have the function called root sum, and the object is a function type. And then we say, oh, the next step is result. So from here, we open a new function frame. So because we call the function, so it creates a new frame, and the frame will be run. So the function code will be run inside the frame, like the codes inside the function. So you in like we have all the inputs here. So x equals to 1 and y equals to 4 and z equals to 9. Yeah. Uh, and then you read the next line again. So it's a solution is square root of x, square root of y, square root of z. So we return, the solution value like after the calculation. So we are going to return this solution. So return it to the root sum, to the result. Yeah, so result becomes 6 and it receives the return value from the root one. So this is how the function is uh the values and the function being being captured. Yeah. Okay. So some summary about the environmental diagram is everything starts from the global frame, and then the parent frame of a frame is where the function is defined. So the function creates a frame. Let's see. The function creates this frame, and the parent frame of this frame is where the function is defined. And we will encounter an example very soon. So a function definition does not open a new frame, and a function call does open a new frame. So yeah, and the parent frame is and the variables not defined in the current frame should be looked up in its parent frame and parents frame until to the global frame. If they cannot find the variable in the global frame, they will say, oh, you have a name error because you don't have a variable name something like you want to look for. So yeah, so you raise an error. Okay. So this is an environmental diagram. We're going to uh, have a little review. It's a new code. It's a new Python file I just wrote a few hours ago. So yeah, if you have a pen and a piece of paper, you just draw with me. I don't need to one note. Say okay. So we just see like we have some codes here. So we're just gonna to run from top to bottom. So see like the first thing is global frame. Uh, oh, so it's global frame. And um, so first thing is x equals to 1, y equals to 6, and z equals to 3. So and then we hit the function definition. Uh, so we know this is a function 1. So it's a function. type. The parent is the global frame. And then we skip all of this until we hit the very last one. So it's a solution. From here, we're going to open a new frame. So the new frame will be F1. So F1 is function 1, and the parent is global, and arguments of the function is x and y. And then you see, oh, I have to evaluate y on the global frame. So it will be the x in frame 1. So it is 6. So the x is 6. And for c on the global frame is 3. So y is equal to 3. Okay. And then I'll have a equal to 5, b equals to 4, and c equals to 1. Yeah, and then we notice that we have another function here. So see a function definition, you read it and then skip it. So function 2 is function type. But notice that the parent is frame 1 because function 2 is defined in frame 1. Yeah. And then we're going to return something. Return a plus b, and a plus b is 5 plus 4 plus. Okay, so we hit another function call. So we have frame 2. Function 2. Parent is frame 1. Yeah. And then we return to the frame 1 code here, and then we know that the x in frame 2 is the sum of x and y in frame 1. So the sum of x and y is 9. Yeah. And then the return value is x times c. So we know that x is 9. So x is 9, and then plus c. So we have to look for the c value in frame 2. But you notice that we don't have a variable named c in frame 2. So then we return to the parent frame. The parent frame of c to f2 is f1. So we return to f1. You see, oh, I don't actually find the c value here. Oh wait, oh, okay, I found c value in f1. So we will use the c value in f1, and then it times 1 by some people may notice that we also have a c equals to 3 here, but it's in global frame. We already found it in frame 1, so we don't have to skip to global frame. So yeah, so we have 9 times 1 is 9. So we return value to here. It's 9. So we got 18. So we return the value to the solution, and the solution is 18. Yeah. Okay. Yeah. Any questions about it? Like we got solution is 18. Yeah. And then we have a demonstration here. So okay. So we recognize x is 1 on the global frame. We start everything from global frame. So we have x equals 1, y equals to 6, z equals to 3. And then we read about the function definition, and we only read it. So we read it and we skip it. Then you see function 1 is the function 1, and parent is the global frame. And then we have another solution. Okay, so we start a function call. So we start f1. F1 is the frame created by function 1, and then the parent frame is global. So we type in all the values is x is the y on the global frame, so 6, and y on the f1 is c on the global frame, so it's 3. And then yeah, We recognize A is 5, B is 4, and Z equals 1. And then we recognize another function. So we recognize it and then we skip it. So function 2, oh, is function object. So parent is F1. Yeah. So we know we are going to return. So we're going to return this, but we have another function call. So it's function 2, and it's frame 2, and the parent frame is frame 1 because the function is defined on frame 1. So we know x plus y on frame 1 is transformed into the argument x in function 2. So the x on the frame 2 is x plus y on frame 1, so it's 9, 6 plus 3. So um so we get x equals to 9 here, so return x times c. So we return 9 because we see like we find x here, and then um we have to find what c value is on frame 2. We couldn't find. We look into parent frame 1. So we found the c value on frame 1. So it's 1. So and then we will return 9 because we return 9 from this function call. So return 9 to frame 1, and it will return 18 because a plus b is 9. 9 plus 9, 18. So we return the value again to solution variable. So solution is 18. Yeah. Yeah, it's yeah, questions, comments, concerns about what I've just said about environmental diagram. Okay. All right. So hopefully you can know about it and practice it a lot. Like maybe I'm going a little faster, so you just say I have to slow down something. If you think I'm going too fast, yeah. Because it's actually you don't actually have to read all of the file from beginning. You just say like, oh, I read from the first line is global frame and XYZ and list all of them, and then I'll recognize a function. You just skip it. You don't have to look into it until they call the function. When you call the function, you just like type in all the values into the argument, the inputs, and then you keep track of all the values. Maybe creating something new there. Then if there's a function definition, skip it. Like if there's a function call, like you type in all the inputs there, and then you go into the function, the codes below the function, like it belongs to the function, and then you find out, oh, okay, some algorithms and something, do some simple calculation, and then you return it, return to where the function is called, and then you add it up together and return until the first function call you called. Yeah, and maybe stand like that's the end of the code file, something. This is the environmental diagram. Like these are the summaries of it. Like it's very important, especially from the third and fourth line. Yeah. Yeah. Any questions about environmental diagram? Like because from this second we are not going to talk about environmental diagram. Uh, kind of, yeah, until the end of our class. Yeah. Okay. Because we are going to add something new into it. All right. So okay. Okay. So going to our topic. Pure function. Yeah. Pure function means a function only return one thing when it's called. Like when you execute a function, you only return one thing. And non-pure function means that when after I return something, I'm going to use it. Like there will be other things. There might be some outputs. Like so, pure function only have one output, and non-pure function may have two outputs or more. Okay, so a very popular non-pure function is print function. Yeah. Like, oh, wait, okay. So pure function, you have input and you only return an output. And non-pure function, such as the print function, you have the input and you display something first, like kind of like print something, display something. Maybe you don't want to. Maybe like it's actually not the output, but it's just display anyway. And then you return something, like you display something, it is visible, and maybe you return another thing is invisible. Um, is
会数是
invisible.
他妈谁？
What is that?
会数还不
What is that? Okay, never mind. So we will return something that may be visible or maybe invisible. So the common of non-pure functions that it has side effect, like kind of like when you intake some drugs and something, you may have side effect like it cures your disease, and maybe you have some things like headache and runny nose, something like that. Like you may not expect to happen. Yeah. Uh, so the print function display the input string and then you return none. So I have a I have a kind of model to I have a model to talk about it. Like when you say this is a pure function, um, here's the input. Like you goes the algorithm and you only have one output. This is pure function. For non-pure, um, you have input and then you also have output, but you also have something unexpected to happen, something like some side effect uh, that may happen uh, into into the code. Yeah. So this is pure and non-pure. We have two models about it, and we have a very classical one, and it's A, like print hello world. So uh, when you first learn Python or any other language, you like try to print a hello world string, and you only know like, oh, I have a print hello world. That's it. Like maybe you have thought about putting it to the right side of the assign operator. And today we're going to discuss what we'll produce after being assigned. So it's A equals print hello world. So it will obviously display hello world instantaneously. And then, yeah, this is the print function. So, and then you want to type A, like what is bound to the variable A is actually none. Yeah, like the logic of print function, a very typical non-pure function is that like I have this model. So I have input. So this is hello world. And then I have output. The output is actually just none. But for the display, we will have the hello world string printed on the terminal. Okay. So this is how print function works. And we can have a little demonstration. So, okay. Say A equals to print, let's say DVC shutter, and you display DVC instantaneously, like immediately, even though I actually don't want to print, like don't want to display something, it will display though. And then you type A equals to none to see if that's true or false. That's true. So that means A is actually none, like nothing is bound to the variable A. So this is how non-pure function works. Mhm. And the print function inside the function, yeah, not this purified though. Like you have a define text x, and then you return print x plus one. So when you type x equals to test one, it will display two anyway though. like um you might not want to control it. Uh, you might want to control it or might not, but it will display though. And then you type x equals none, it's true. Like x is none. And definitely okay. Oh, uh, not sure I can do a demonstration. Like the computer is getting stuck. Mm, yeah, I'll do about it later though. Okay, so anything about the pure and non-pure functions we like to talk about. Okay, so the lambda function. Okay, lambda is actually a Greek letter. So maybe you use it a lot in math class, and for computer science, lambda is kind of like another function. So lambda is written like this, and lambda function is actually a very fast function definition. So typically we have the function keyword and the name, input, output, return statement, and maybe some algorithms into it. But for lambda function, we actually do a very fast function definition as fast as we only use actually usually one line to solve it. So this is example of a lambda function. So we have this function name, and then we set the equal sign. So we say lambda, and this is the argument x, and the column, same as the typical function. And then we have the function body is actually like a kind of short. We usually do some calculation, maybe or true or false. Like it will only return maybe a number, um, or true or false, or maybe like display something. Yeah. So the format of it is lambda is the keyword, and then you have the argument. There may be one or maybe two. So, and then there's a column, and then you have the function body. Yeah, very short. So it returns 16 for the line 3. So when you say, oh, I want to execute this like kind of like a typical function, so we recognize it and we skip it. Like not until we have a phone call. Oh, sorry about it. Yeah. Sorry about it. Um, yeah. So we have the function called lambda. So we input 4 here, input 4 into the x function. So we return 4 times 4 is 16. So we'll return the value 16 into it. So we bound 16 to the variable x. Yeah. Yeah. Any comments about it? Okay. So fast function definition is same as an ordinary function. Is parent frame is also where the function is defined. So um, so we define the function on the global frame. So it's also p equals to global frame. Yeah. Okay. Um, when it's defined, it does not open new frame. When it's called, it opens a new frame. Same as a typical function, but it's a very fast function definition. Yeah. Um, this this is the format of it. Lambda keyword and argument, column, function body, uh, keyword, and the argument, column, and the function body. It's usually a formula or inequality, or maybe you have like something like print. Maybe, yeah. It's also reasonable. Hmm. This is what I say about the true or false. So we have lambda for 5. We input this, so it's 4 and it's 5. Um, And then we have 2 times 4 minus 5 is a minus 5. So it's 3. So 3 is obviously greater than 0. So it will return false to x. We bind the variable false to x. Yeah. Um. Yeah. Okay. Any comments about it? Okay. Right. So yeah, the same thing. Definition does not open a new frame, and the function call does open a new frame. Yeah. Same as a typical function. So this is the environmental diagram of a lambda function. So we just um, recognize the function first, and then we had the function call. So we open a new frame. It does not open. It does not open a new frame, but then when you call the function, although it's a lambda function, you have the function. You have the function new frame, and the function opens the new frame. Okay, so we input 4 and 5 into the function x, y, and then yeah, and then we'll return false. Yeah. Okay. So anything about the lambda function? Any questions about the lambda function? Mm. Maybe I'll do a little demonstration. If only that works. Okay. Guess. Yeah, I have tests and a lambda. Yeah. Okay. So and no such file. Uh, uh, oh, yeah, did what? Oh my God. Sorry. I don't know. Uh, oh, I'm running this. Oh, okay. So we do the print function first. So we say 2 equals test a, uh, a equals to c 2. Oh my God. Okay, so when we have a equals to test 2, it will display 3. Because eh, because I will print it first. Like as long as I hit the function, I will display what's inside of the print function, and then we'll say what's a. Like a is actually nothing because it's none. If you want to see specifically, a equals to none, is it true? Yeah, it is true. Okay. So for the lambda function, we have the lambda equals to lambda x and x times x. Okay. So we can try b. Lambda 9. Like b is 81. Then we can also try like true or false problem. Kind of like a times x, 2 times x plus a less than 0. So yeah, so we see c equals to lam. Oh, I have to save it and then try again. Okay, so we c equals to lambda. Let's say uh kind of like 9. Can try 9. So 2 times 9 is 18. 18 plus A is obviously false. Yeah, so it's false. It's like B equals to lambda negative 100 and B2. Yeah, okay. Yeah, you can see my screen. Okay. So uh this is how lambda and test like the two function, how's they gonna like. And yeah. Uh do you have any questions about the pure function and also the lambda function? You can also type in the chat box. Yeah. If you have fun, yeah, if you have questions. Hmm. Uh, okay. Mm. So yeah, there's a little time left. We can try a practice problem about also drawing the in-random diagram. Yeah, so good. Okay. Let's have about 10 minutes to draw the in-random diagram of this code. This code, like we have a 12 lines of codes. Let's start from now. Like we'll have the result from at A49. Like you like if you have an iPad or a pen with a piece of paper, like I really appreciate that, and you can start drawing it. Yeah. We also have the lambda function. Um, I can I can try. Yeah. Yeah, you can try doing it. So same as what I said, like lambda function is just a regular function. Like maybe it's kind of short. Yeah, but it's also you can treat it as a regular function. Mhm. Yeah. Yeah, if you have any questions, like you can either just set to it, like say to me or type it on the chat box. Mm, I guess I have a small hint though. Um, well, like when you hit the line 4, you say test. Um, you evaluate test is something, and you say this is a function. You can say lambda and x, y, and the parent is global frame. This is how test is being read and recognized. Mhm. Hmm. I guess the result is 10. Like, mm, okay, all right. Yeah, how you doing, guys? Uh, about it. So let's see. Yeah, the result is 10, and we'll look it through every step. Okay. So I'm going to copy this to. Oh my God. Okay. So okay, going to have this here. Oh my God. Uh, all right. We're going to look it for every step. Mm, so we have the global frame. So the global frame X is 1, Y is 6, Z is 3. We have test function lambda, X, Y, and then parent is global. Mm, And then, yeah, like we read it and then we skip it. We haven't called that. So we have the uh, function object, func x, y, and then parent. It's also global. Okay. Recognize and then skip. Next step, solution. Okay, so we have a function call. So the name is func, and we will input the y and z value on the global frame to frame one. So we have the frame one open from here. So frame one is func one, or just func. Parent is global. Yeah. And then we'll see, oh, the argument is x and y. Mm. So what is x? X is y on the global frame. So its y on the global frame is 6. So x is 6. And z on the global frame is 3. So it will be the y on the first frame, frame 1. So y is 3. So we also have a is 5 and b is 4. Yeah. And C is something like, oh, okay, so it's a function call. So this is the function call from a Lambda function. We have another frame two. So we have lambda x, xy actually. So xy, and parent is also global because when we see here, it's defined on the global frame. So we have x plus y plus c. So okay, so then we return to x plus y. Uh, actually, okay. We may have xy to be more clear. Uh, so the lambda x is y on frame. So y is 3. So the y on frame 2 is b. B is 4. So 4 is f. So it's y on frame 2. So we return is 3 plus 4 plus c. So what is c? Uh, so c is here. So we know that like the lambda function is defined on the global frame, and then we have frame 2 here. So we will look for c on frame 2 first. If we see, oh, we don't have a variable called c, so we'll return to the parent frame. So it's global frame. So on the global frame, c is 3. So we will say 3 plus 4 plus 3. C is 3. So we will have 10. So we return the value 10. So where we gonna return? Return to F1, to C, or to C. C is 10. And then we do the return because the last step is return. Like, is it? Yeah, it is return C. So return C. C is 10. So we return 10. So where we're going to return to? Return to solution variable on the global frame because we have the function call on the global frame which is bound to solution, the variable called solution. So we will have solution 10 here. Yeah. So um, any questions about it? Maybe, oh, I'm getting faster again. Uh, yeah. So. Mm, Yeah, you just go step by step and recognize the function. Oh no, it's a lambda or it's a regular function. And then you skip to solution. And solution is a function call. So what is that? You have to return a new frame to know what that actually is. So return to frame one. So parent frame is global for the function. And then you have x equals to 6, y equals to 3, but you evaluate the stuff from the global frame, and then you have A, B, C. You have A, B, which is already have given values, and you have C. Oh, you have to open a new frame, on the like F2. So in the F2, the lambda function, so you also type in the arguments from the frame one. Yeah. So arguments are from the function where it's called, and um, the parent frame is from the function is from the where the function is defined. Yeah. So x is 3, y is 4, and you return C. We couldn't find C on frame 2, so we look into the global frame, which is the parent frame of frame 2. So, okay, so we find Z is 3. So you use 3 as C. You replace Z with 3. Yeah, so you have X, Y, Z. So X is 3, Y is 4, and Z is 3. So you get together, you become 10. Okay, so I also have Python tutor demonstration. Uh, really quick, real quick. So, yeah. Oh, the same thing. Oh, okay. So global friend XYZ, and we will recognize this is a function. Lambda, although it's lambda, and but it's also a function. So you say, okay, it's a function lambda, and the parent is equal to global. And if you're good, you can write down the lines number here because in future you may have a bunch of lambda functions, like maybe 3, 4, or maybe 30, 40 functions, and you can locate each function because you only know this is a lambda function though. Yeah. And then you have the define func, you recognize it, and then you skip. Yeah. And then you have the solution. Solution is the function. Oh, we have to open a new frame because we have a function call. So we have function yz. So um, so we have function xy is in the frame one, but we have to evaluate yz, so we can treat them as an input of function. So we'll evaluate them on the global frame. So y is 6 and z is 3. So okay, so we have xy. Then we have a and b. Yeah, notice the arrows here. Yeah, so have a, b, 5, 4, and then c. Oh, I have to know. Oh, what is that? Again, you open a new frame, and okay, the lambda function on line 5. So parent is global, and you have x, y. So x, y is 3, 4, and yeah, because y from the second frame is, oh, y from the frame 1 is 3, and then b is 4. So we have 3, 4. So for the c, you just return 10, like because you couldn't find Z on frame 2. You have to look into its parent frame. So on the parent frame is Z is 3. So you use 3 as Z, and then you use X plus Y plus Z. So it's 3 plus 4 plus 3. So you get 10. Yeah. So you return the value to C, and then you return C to the variable called solution. Yeah. Okay. So any questions about it? About function, lambda function, pure non-pure function. Yeah. And yeah, maybe I can show you uh the define test, the print function. Okay. So you have the print output here on the Python tutor, because just as a non-pure function, you display something you're not going, like, not easy to control. So like when you go into X here, so notice that like we only had the function definition on the line 1 because we are now on the global frame. So we are not going to run the code inside the function. You know, oh, this is a function, so we skip it. You just know there's a function. And when you actually have x equals to text2, so this is a function call. So we have to get the input into the x, and then you run the run the code inside the function. So you have two here, and then you're going to return. So the next we'll have both things happening here. We will have print. Because we have x plus 2, x plus 1, x is 2, so 2 plus 1 is 3, but we only print that and display that, and that's it. And we will return none because print function returns none. Yeah, return value none. Yeah, all right. Yeah. Oh, okay. Any final questions and comments, concerns about this lecture? Yeah. Okay. From next week, we will use function from like for the rest of the course, and uh, we will have control statements for the next week, and we have if statement in Python, and we have iteration. For iteration, we usually have for loop and while loop, but we only talk about while loop next week, and we talk about for loop I guess many weeks later though, like because they are actually different though. Yeah, they are actually different loops, but yeah, basically same. Um, and yeah, uh, I think that's it. And I will share the like the documents and my maps later and the records. All right. Thanks for coming to the lesson this week, and hope you have a wonderful weekend. Yeah. All right. The class is over. Mhm. Okay. Thank you. Yeah. Thanks for coming to the course. Mm. Very sorry about the phone call. I wasn't expecting that, and yeah, my mind went blank, and actually, like the presentation of that part is a little bit like uh shabby, and yeah. All right. Okay. See you next week. I'm gonna end this meeting. All right. See you guys next week.